You can turn your data into opportunity with the Microsoft Power BI and its complementary data visualization tools. Drive better business decisions by analyzing your enterprise data for insights. But how are you going to do it if your data is not ready for the analytics to be layered on top of it? Microsoft Power Query provides a powerful data import experience that encompasses many features. It works with analysis services, Excel, and Power BI workbooks with a core capability to filter and combine and transform your raw data sources into a more usable, workable data model. Hi all, I welcome you to this session on Power Query in Power BI. And today I shall take you through the most important step in your business intelligence solution, which begins even before you start working on your data. And that step, my friends, is the Power Query. But before we begin, let's look at our agenda for today. So first off, we are going to start out by discussing a little bit about Power Query as well as the M formula language, which is an integral part of Power Query. Then we are going to discuss a little bit about our problem statement, in which we are going to introduce to you the data set on which we are going to work today. That is the infamous Titanic Voyage dataset, which shows who survived the iceberg and who did not. Followed by which we are going to learn how to retrieve data from a certain data source using Power Query, and then making transformations and changing that data to suit our needs, making it a more usable form of the data source. In that particular module, we are going to remove columns, promote values, rename the dataset, filter rows, replace values, as well as add calculated columns to the dataset. We are going to navigate the Power Query feature using the M formula language. And finally, we shall conclude the session by discussing a little bit about the scope of this feature. With that, I come to the end of my agenda for today. So without much ado, let's get started. In the Power BI desktop, a data set is basically defined by a single query that specifies what data to include and how to transform that data. Power Query is a data connection technology that enables you to discover, connect, combine, and refine data to meet your analysis needs. It basically helps you take your raw data source and convert it into something more usable, more workable, on which you can build your analytics and then draw insights from it. The query is made up of related steps that build on each other to produce the final data set. And once you've defined that particular data set, you can use it to create visualizations that you add to your reports, which then you can publish to the Power BI service. Now, at the heart of the query is the Power Query M formula language, which is based off of a language called F#. And just like it, it is a case-sensitive data mashup language which is available to many of the Microsoft softwares, such as the Power BI desktop, Power Query in Excel, as well as the Get and Transform import feature in the Excel versions post-2016. As with many languages, Power Query statements are made up of individual language elements such as functions, variables, expressions, as well as values, both primitive and structured, that together define the logic necessary to shape the data. Now, each query in the Power BI desktop is a single Power Query let expression. It basically contains all the code elements that are necessary to define your data set. A let expression is made up of a let statement and an in statement, as you can see in the syntax before you. So the let statement includes one or more procedural steps that define the query. Each of these steps is essentially a variable assignment that consists of a name as well as an expression that provides the variable's value. Pretty simple, that is what a variable is in most cases. It's 5th grade math, right? Variable is a name to which you assign a value. Now, this expression defines the logic for adding, removing, or transforming the data in a specific way. This is where you will be doing the bulk of your work, as you are going to see in the examples I'm going to give you later in this module. Now, the variable can be of any supported Power Query type. Each variable within a let expression must have a unique name But again, the Power Query is fairly flexible about what you call it. Just make sure it makes sense and it's easy to remember for you. Now, you can include spaces in the name, but you have to enclose it within double quotes and precede it with a hashtag. Now, that is a somewhat cumbersome naming convention and one that I particularly prefer to avoid. It's honestly a mystery to me, even now, why it is the way it is, but let's just move on. Now, the variable names are also the same names that are used to identify steps in the applied steps section in the query editor's right pane. So I think it would be wise to use names that make sense. Now, strictly speaking, you do not have to define your procedural steps in the same physical order as the logical order. As in, for example, you can reference a variable in the first step of your procedure and then define it at the last step of your procedure. Now, this is something which is unlike the regular coding. However, this approach can make the code very difficult to debug, as well as cause unnecessary confusion amongst the coders. The accepted convention when writing a let statement is hence to keep the physical and logical orders in sync. Now, we spoke a lot about the let statement and none about the in statement. So a little input here. The in statement is basically like a return function. It returns a variable value that defines the dataset's final shape. Now, in most cases, if not all, this is most likely to be your last variable that you defined in your let statement. You can specify a different variable from the let statement, but there's usually very little reason to do so. So if you simply need to see a variable's value at any specific point in time, you can select its related step again in the applied steps section in the query editor. If you are not familiar with what it looks like, I'm going to show you in just a while once we open the demo machine. Now, when you select a step, you're essentially viewing the contents of the associated variable. With that, let's move on to our problem statement. Now, this session is going to include a number of examples that demonstrate how to define the procedural steps necessary to build a query. All of the examples are going to be based off of a data set, the link to which I will leave in the description box below. Now, the data set I'm going to use is the Titanic data set, which lists the passengers on the infamous Titanic voyage. It basically shows who survived it and who did not. Now, if you plan to try these examples for yourself, you need to create a titanic.csv file from the dataset that I'm going to link in the description box below and save it to a folder that you can access from the Power BI desktop. On my system, I saved it to a local folder in my C drive. Now, understand what we are trying to do here is to make this particular dataset a little more usable for you to lay analytics on top of. Yes? So now let's move on to Power BI and see how to do that. So the first step into building your own Power Query script is to add a blank query to the Power Query desktop. Now, to do that, what we're going to do is we have this Get Data button on the Home ribbon in the main window. So I'm going to click on that. All right. Then I am going to navigate to the Other section. And towards the very end, I'm going to find this option called a blank query. So I'm going to double click on this, or you can even click on Connect. Now, what it does is that it launches this query editor with a new query listed in the queries pane on the left. Now, it's conveniently named query 1, or you might have a similarly numbered name with a different number depending on how many queries you've created. Now, to rename this query, what we're going to do is we are going to right click and select rename and maybe give it a fitting name like survival log. Okay. And then we are going to press enter. As simple as that. On the right in properties, you see the name has changed, which earlier was query 1. Next, let's go to the view menu. It opens up this ribbon and then click on advanced editor. Then it opens the advanced editor. Now, as this editor opens, you can see that there is a new let expression here, which is already defined. The let statement includes a single procedural step in which the variable is named source and the expression is an empty string. As you can see, it is indicated by double quotes. Notice that the variable is also listed in the in statement, again, source. And if I move this advanced editor a little to the left, you can see that the variable is even listed as a step in the applied steps section. Now, this is the part I was talking about earlier when I talked about applied steps. Now, this is that section. Here you can see all the steps that have been applied to your query editor, and you can click on each step to see what that variable holds. Now, for this exercise, we'll be changing the variable name to get passengers. So the first procedural step that you'll add will retrieve the contents of the 𝐵𝐼𝐻𝐻.csv file and save them to get passengers variable. Now, to add the procedure, we are going to replace the current let expression with a different one. Notice that this get passengers variable is specified in the procedural step in the let statement as well as in the in statement. Now, in this way, the variable's value will be returned when the let statement runs. It's as simple as that, as I had earlier mentioned, that the in statement is basically like a return function. Now, this expression in the procedural step includes everything after the equal sign. The expression uses csv.document as a function to retrieve the file's contents as a table object. It supports several parameters, but only the first one is required to identify the source data. As a part of the first parameter, you must also use the file.contents function right here to return only the documents data. And here you can see the location of my dataset. As I had already mentioned, it is saved in my C drive in a local folder called data files, and my file name is titanic.csv. Now, the second parameter can be specified as a record that contains optional settings. So in Power Query, a record is basically a set of fields which is made up of name value pairs enclosed in brackets. Now, the record in this example includes a delimiter and encoding options for the values. Now, the delimiter option specifies a comma, as you can see right here, as the delimiter in the CSV document, and the encoding option specifies the text encoding type 1252, as you can see right here. This is basically the Windows Western European code page. Yes? And that's all there is to know and all there is to setting up a basic let expression in your Power Query. After you've entered your code, click on Done and close the advanced editor. And as you can see, that has run the procedural step, and the data set appears in the query editor, and it should look similar to what you can see right now. It's got a couple columns, it's got the survived, it's got names, it's got sex, age, passenger class, so on and so forth. Notice that the first step in the applied step section is now named get passengers, which is the same as your variable name. The procedural steps expression is also displayed in the small window above the data set right here. Now, you can edit the code directly in this window if you want to. Whenever you add, modify, or delete a step, you should apply and save your changes. A simple way to do that is to click on this little save icon at the top left corner of the menu bar. When prompted, if I click on this, I will be prompted to apply my changes. And here I am going to click on apply. And with that, my query is saved. Moving on, another important thing is removing a column from the data set. Now, the next procedural step that you're going to add to your let statement basically will remove your duplicate column or column 6 from your data set. Now, because your data set is saved as a table object, you can choose from a variety of Power Query table functions to update the data. For this step, you'll use something known as remove columns function to filter out that specific column. So again, I'm going to click on the advanced editor and I'm going to get back to the query. Now, basically, to remove the column, I am going to add a comma, give a space, and on a new line, I'm going to define the next variable or expression pair Now to remove the column, add a comma after the first procedural step and then on a new line define the next variable expression pair as you can see on your screens. The table.remove function requires two parameters. The first parameter specifies the target table that you will be updating, which in this case is the getPassengers variable from the previous step. Second argument specifies a single column or a list of columns to be removed. This example specifies only column 6 from getPassengers table. The important takeaway here is how the second step builds on the first one and then returns a new result, which is assigned to the removeCalls variable. The new variable contains the same data set as getPassengers variable, just without the column 6 data. After you add this particular procedural step, replace the getPassengers variable in the in statement with removeCalls variable and next click Done to close the advanced editor. You can then save and apply your changes. Your data set now should look something like this with 5 columns only. As you can see, the removeCalls step has been added to the applied steps section as well. And column number 6 is no longer included in the data set. To add more procedural steps, we follow the same logic as here, continuing to build on our growing foundation. The next step is to promote the values of the first row of your data set to the header row. So these values become the column names. So to carry out this step, again, go to the advanced editor. Now to carry out this step, add a comma after last step that you defined and then on a new line you can put the expression in front of you. This expression uses the table.promoteHeaders function to promote the first row of the column headers. The function's first parameter is required and specifies the table to use as the source data. This is just like you saw in the previous example, in which the new step builds on the previous step. The second parameter, promote all scalars, is optional but a good one to know about. By default, Power Query promotes only text and number values. When promote all scalars parameter is included and set to true, Power Query promotes all the scalar values in the first row to headers. The expression results are assigned to the promote names variable. Be sure to update the in statement with this variable name. Again, I'm going to click on done. And as you can see, our entirety of first row has turned into this header row right now. The rename columns function requires two parameters as usual. The first is the target table, which is the promote names variable from the previous step, and the second is a list of old and new column names. This is a list of an ordered sequence of values separated by commas and enclosed in curly brackets, as you can see before you. It's this entire line. And in this example, you can see each value in the list is its own list containing two values, the column name and the new column name. So I'm going to click on done. And voila, you can see all the names have been changed. Now the next task is to filter out rows that contain not applicable in the age columns and then filter out rows with age values 5 or less. Now because the age column was automatically typed in as text when imported, you will need to filter the data in 3 steps, starting with the non-applicable values. Now to filter out these values, you will need the select rows function. Now, this function returns a table that contains only the rows that match the defined condition, age not equal to NA. As you saw the previous examples, the function's first argument is the target table, which is rename columns from the preceding step. The second argument is in each expression specifying that the age value must not equal NA. The each keyword indicates that the expression should be applied to each row in the target table. As a result, the new table, which is assigned to the filter NA variable, will not include any rows with the age value of NA. Clear? Now, once you remove the NA values, you should convert the age column to the number data type so you can work with the data more effectively. such as being able to filter the data based on numerical age. While changing the type of the age column, you can also change the type of passenger ID column to an integer 64 type. This way, you're referencing to the IDs by integers rather than text, as you can see right here. Now, to convert to the new data types, you should use this particular expression. Now, this uses the transform column types function to change the data types. The first parameter is the name of the target table, which is filter NA, and the second parameter is the list of columns to be updated along with the new data types. Each value is its own list that includes the name of the column and type. Once the age column has been updated with the number type, you can filter out the ages based on numerical value. Your dataset should now include only the desired data as it exists in the filter kids variable. Now, another handy transformation you might need to do at all times is to replace one column value for another. For this example, you will be replacing the 0 value in the survived column with no and the 1 value with yes using the table replace value function. Now, kindly refer to the syntax that is shown to you and try to transpose the following elements that I'm going to discuss with the syntax on your screen. Now, the table replace value function requires 5 parameters in total. First, you have the table, which is the target table, in this case, the variable from the preceding step. Second, you have the old value or the original value, which has to be replaced. Then you have the new value, which you will replace the old value with. Then you have a replacer that carries out the replacement operations. And finally, you have columns to search. Now, the column or the columns whose values should be replaced. Now, most of the parameters should be self-explanatory except perhaps the replacer parameter. For this, you can choose from the several functions that work in conjunction with the replace value function to update the values. In this case, the replace text function is used because text values are being replaced. So first, what we're going to do is that we are going to replace the 0 values with no. And after you replace the 0 values, you can replace the 1 values with yes using the same construction. Here you have your old value, which is 1, your new value, which is yes, the table, which is the replace 0 table, the replacer, which carries out the replacement function in the column survived. And then finally, I'm going to change variable at in. As you can see, I have changed the variable for replace 0 and hence all the 0 values have become no. Now let's go ahead and do the same thing for 1. And there we are. Now another way you can modify your column values is to change how capitalized they are. For example, you will update the values in the gender column so that the first letter of each of the words is capitalized rather than all being in lowercase. To make these changes, again, let's go back to our advanced editor, add a comma. Now again, this expression uses the transform columns function to update the two values. The function requires 2 parameters. The first is the table to be updated as usual, and the second is the list of operations to carry out. At times, you might need to provide additional information, but that's not the case always. For this example, there's only one operation, so you need to specify that the gender column and the text.proper function are enclosed in curly braces. The function converts the first letter in each word in the gender column to uppercase. At this point, your let expression in its entirety should look similar to what you see on the screen right now. The let statement includes all those steps and makes up your query to this point. Now, with each step building on the preceding step, let's click on Done, and you see the gender column with capitalized first alphabets. And on the right, you see the applied steps. And notice that the applied step section includes one step for each variable defined in the let statement. And all of them are specified in the same order that they appear in your statement. If you select a step, let's say this, the data displayed in the main windows will reflect the contents of that particular related variable. If I click on this, You see, we are back to the step where the ones were not replaced with yeses. Now, up to this point, each procedural step in your let statement represents a discrete action that is built on the preceding step. In some cases, however, you might need to structure your steps in a way that is not quite so linear. For example, you might want to create a calculated column that shows the difference between, say, a passenger's age and the average age for that person's gender. So for that, we need to first calculate the average age of the female passengers and save it to a variable, then calculate the average age of male passengers and save it to another variable. Or you can do it vice versa as well. This is optional. Then you can add a column that uses the two variables to calculate the age differences and round the age differences to a more readable number of decimals. Now this step is purely optional. Now to carry out these steps, again, I'm going to put a comma, go to the next line, and add a couple of steps. Now, this suddenly might have caused a lot of confusion. So what I'm going to do is I'm going to walk you through these steps in smaller chunks so you can better understand how they work. Now, the first line, which is preceded by 2 slashes here, which says add calculated column based on average ages, indicates a single line comment. Anything after the slashes to the end of the line is purely informational and does not get processed. Power Query also supports a multi-line comment that begins with a slash and a star and ends with star and slash, just like the multi-line comments in the SQL server if you might be used to that. It's up to you whether you want to include comments or not. Whether or not you do, the next step is to calculate the average age of female passengers. So these are the two steps. The first step uses the select rows function to generate a table that includes only rows with a gender value of female. The function is being used here in the same way you saw earlier, except that different data is being filtered out and the results are being saved to female variable. Notice that the source table for the function is the change case variable from the preceding step. The second step uses the list average function to calculate the average for the age values in that particular table, which is the female table. The expression returns a scalar value, which is then saved to the average female variable. The function requires only one parameter. The parameter includes a second function, which is the table.column, which passes the values from the age column to the list average function. All right, so let's run these two and see. Now you can see we have the average female age right here, which is 30.7, a lot of 2's and 1. Moving on to the next 2 lines. Now we're doing the same thing for the male passengers, and for this you can use the same construction with a few minor changes. Notice that you must again use the change case variable for the source table when calling the table.selectRows function. Even though it's no longer the step directly preceding the new one, you can in fact use any of the previous variables in your expressions as long as it makes sense to do so. With the average female and the average male variables in place, you can now also add a column using the add column function, which is this one. The table.addColumn function requires 3 parameters. The first is the target table, which is again change case, and the second is the name of the new column, of course, which is the age difference column or age diff. So let's run all of that and see. And now you can see the average male age is around 32 years old. Finally, let's run our add column variable. And if we go to the extreme right, we see our new column with age difference is right here. But then there is an issue, isn't there? Let's go back to the advanced editor. Now, as you can see, this particular argument, the third argument, is the expression used to generate the column's values. The expression starts with each keyword which iterates through each row of the target table. Now this is followed by an if-then-else expression that calculates the row's value based on whether the passenger is male or female. If the gender value equals female, then the age difference value is set to the age value minus the average female value. Otherwise, it is set to the average male value. But as you saw, all the values are in negative and have way too many decimal values specified. So after defining the new column, the final procedural step rounds off the age difference values to 2 decimal points. The expression includes the transform columns function, which you saw earlier, but it uses the number round function to round off the values rather than changing their case. The number round function takes 2 parameters. The first value is an underscore, which represents the column's current value, and the second is the value 2, which indicates that the value should be rounded off to 2 decimal places. That completes the steps necessary to create the calculated column. Your let expression in its entirety, after you change this to round diff, your let expression in its entirety should look something along the lines of this. All right. It should look something like this. This code I will also leave in the description box below. I'm going to click on done, and here you can see the age difference in plus and minus, whether people go above the age average or below. Now notice that the applied steps section includes variables used to find the average ages, even though the add column step in the code builds on the change case variable. You can view the contents of these variables by selecting each step as I had done before. And if you select one of the variables used to store the actual average, the query editor will display it on its scalar value, as again I had shown it to you before, but again if I click on average male, it shows a scalar value. Now the query only shows the contents of the average male variable, a rather lengthy number, and now you can see why I included the final procedural step to round the values in the calculated column. Not surprisingly, there's much more to Power Query than what was covered in this particular module. But this should give you the foundation you need to start building your own queries in the Power Query desktop. It should also give you a better understanding of how these queries are constructed when using a point-and-click feature to import and transform your data. In this way, you can examine the code to better understand why you might not be getting the results that you expect. You can also start building your own query by using point-and-click operations, and then use the advanced editor to fine-tune your datasets or to introduce logic not easily achieved through the interface version. To make the most out of Power Query in the Power BI desktop, you'll need to dig a lot deeper into the M language's various elements than what we've covered here, especially the built-in functions. Keep in mind though, the Power Query was built with Excel in mind, so you might run into elements that don't transfer easily to Power BI desktop environment. Even so, the basic principles that define the language and its syntax are fairly the same, and the better you understand them, the more powerful a tool you have for working with the data in the Power BI desktop. I'll leave you with that thought. My name is Upasna. Thank you and have a great day.